there's areas of the Grand Canyon you cannot explore.
You cannot go, you cannot fly over,
Right.
and you can't fly under the rim.
The Grand Canyon is famous for what we can see on the surface, but a recent discovery deep beneath the canyon floor is changing everything we know about Earth's history. Using advanced seismic imaging, researchers have detected a bizarre, structured formation buried miles under the bedrock, and the data is terrifying. This isn't a natural rock layer or a fossil bed. It is a massive geometric anomaly with sharp angles and parallel lines that preliminary dating suggests is over 300 million years old. That means this structure was already ancient before the first dinosaur ever walked the Earth. In a world defined by the chaotic randomness of erosion, finding something this organized is mathematically impossible. Is this a rare geological fluke? Or are we looking at the invisible scaffolding of the continent itself? Today, we are diving deep into the data to uncover the truth behind the structure that shouldn't exist. Reading the Earth's echoes. The story begins with the kind of work most people never picture when they think of exploration. It wasn't a hiker stumbling into a hidden cave or a climber discovering a mysterious door etched into the limestone. Instead, it started with instruments, vast digital grids, and a process of patient, methodical listening. Subsurface surveys do not rely on dramatic torchlight beams or sudden reveals in the dark. They start as quiet, rhythmic patterns in a stream of data. Using a technique known as seismic tomography, essentially an ultrasound for the planet, researchers send pulses of energy deep into the crust. As these waves travel, they bounce off different materials, returning to the surface to tell a story of what lies beneath. Usually, this story is a messy one, filled with the shattered remains of ancient plates and the chaotic jumble of compressed sediment. But in this specific region of the canyon, the data refuse to behave like ordinary geology. A set of readings, repeated and cross-checked across multiple independent studies, suggests that something down below reflects waves too cleanly and far too consistently. In the world of geophysics, the underground is typically a noisy place. It is a landscape defined by millions of years of random environmental violence, where rock is crushed, folded, and broken into a million irregular pieces. Yet, the signals returning from beneath the canyon floor looked less like a chaotic jumble of fractures and more like surfaces that meet at repeatable, geometric angles. This kind of regularity is the ultimate red flag for a scientist. It suggests a level of organization that shouldn't exist at these depths. What makes the structure so bizarre isn't simply the fact that it exists underground. After all, the Earth's crust is riddled with voids, magma chambers, and odd mineral bodies. It is the apparent coherence of the geometry that is truly jarring. We are talking about signals that outline crisp, 90-degree intersections and long, straight planes that stretch for hundreds of feet. When researchers first saw the visualizations, the immediate reaction wasn't one of celebration, but of profound confusion. They checked the sensors for calibration errors. They looked for software glitches. They even considered if the equipment was picking up interference from nearby human infrastructure. But after 3 separate surveys using different technology, the results remained the same. The shape was real, and it was sitting miles below the surface in a layer of rock that has remained undisturbed for hundreds of millions of years. This regularity suggests that whatever is down there didn't happen by accident. It was formed by a process so stable and so consistent that it mimics the precision of intentional construction. Nature's architect or something else. Imagine a region beneath the bedrock where the boundaries seem to form long, continuous planes rather than irregular pockets. Imagine edges that run parallel for distances too long to be comfortable, as if something was assembled rather than merely cracked. Even the way the anomaly interrupts the surrounding rock layers matters. When rock layers bend or break around a feature, they tell a story of when that feature arrived. Early interpretations suggest the surrounding rocks behave as though this object or formation was already there. when the later layers accumulated or shifted around it. This hints at a deep, ancient origin rather than a recent intrusion. Then comes the part that has caused ripples through the scientific community. The age. Dating something you cannot directly touch is a careful chained inference built from the ages of the rocks that encase it. If the surrounding layers can be dated to a particular era and the structure appears to predate those layers, the clock starts pushing backward into a time that feels alien to us, the billion-year gap. The claim that it is older than dinosaurs is not just a single number, it is a bracket. It likely formed before the Mesozoic era, meaning earlier than roughly 252 million years ago. That alone places it in a realm where the surface of the Earth was radically different. This was a world dominated not by the familiar icons of our imagination, but by ancient ecosystems recovering from cataclysmic extinctions and reshaping the very continents. The immediate implication is geological, and it forces us to ask a difficult question. If a feature with such seemingly organized geometry can form naturally, then our instincts about what natural looks like might be far too limited. The Earth is capable of producing shapes that mimic design in ways that can easily fool the eye. Basalt columns can look like tiled architecture, and crystal faces can resemble polished walls. Under immense heat and pressure, rock can fracture in systematic ways, creating planar boundaries far cleaner than the surrounding rubble. Fire and stone, the magmatic theory. However, the sheer scale of this subsurface anomaly suggests something far more complex than a simple mineral vein. The Grand Canyon region sits at the crossroads of a very complicated tectonic history. Long before the canyon itself existed, the crust beneath it experienced collisions and shifts that rearranged rock like layered fabric being tugged. Ancient mountain-building events could have created deep metamorphic zones where minerals recrystallized under steady directional pressure. This process produces aligned fabrics and planar features that can appear engineered to the untrained eye. If the structure is within such a zone, what looks like a wall might actually be a metamorphic boundary, a contact point between two different worlds of rock that formed under conditions we rarely witness directly. The older the feature, the more it may represent a chapter of North America's early assembly, from a time when the continent was still being stitched together from smaller blocks, deep voids, and dark ecosystems. But there is another possibility, one that is equally natural, yet no less mind-bending. The structure could mark the aftermath of an ancient intrusion of molten rock that cooled in an unexpectedly regular form. Magma can force its way into cracks and spread as sheets, creating what geologists call sills. These sills can extend for miles with a remarkably consistent thickness. If subsequent erosion and tectonics exposed and distorted those sheets, the remaining subsurface geometry might appear to the sensors like rooms or corridors. In some cases, magma bodies can cool in stages, building internal boundaries like nested shells. Those boundaries can be planar, smooth, and repetitive. If the subsurface anomaly corresponds to such an intrusion, it could be a snapshot of deep-time plumbing, a remnant of a volcanic heartbeat that pulsed before a single dinosaur ever walked the Earth. The hidden scaffolding of Arizona. There is also the haunting question of voids. If the formation includes cavities, those spaces might not be empty in the way we usually imagine. Deep subsurface voids can host mineral deposits, brines, and even entire microbial ecosystems that have adapted to total darkness and chemical energy rather than sunlight. The older the system, the more time water and rock have had to interact, dissolving some minerals and precipitating others to carve out networks that look strangely organized. In certain landscapes, groundwater can sculpt tunnels and chambers with terrifying precision. While the Grand Canyon's main rock types are well known, the depth of this anomaly suggests a different kind of void-making mechanism, perhaps linked to ancient hydrothermal activity. Hot fluids rising through fractures can dissolve material in ways that create sharp boundaries, leaving behind mineral skins that mimic constructed walls. The final verdict. These implications for the Earth's early environments are substantial. Anything older than dinosaurs sits in a window where the planet's oxygen levels, ocean chemistry, and continental configurations were all fundamentally different. If this structure formed through hydrothermal processes, it could preserve evidence of ancient fluid pathways that are the key to reconstructing past climates. Chemical signatures trapped in these minerals can reveal the temperature and composition of fluids that moved through the crust hundreds of millions of years ago. That, in turn, tells us how heat escaped from the interior of the Earth and how nutrients were cycled to support early life. Even if the formation is ultimately a geological artifact, it serves as a rare archive of a time we mostly know through scattered clues. If you found this exploration of the deep mysteries beneath the Earth fascinating, make sure to join us for more. There are countless secrets still hidden in the shadows of our planet's history. For more deep dives into the unexplained and the extraordinary, subscribe to Mysteries Uncovered Files. Would you venture into the depths of the canyon to see what lies beneath? Let us know your thoughts in the comments below. We want to hear your theories. Thank you for watching, and we will see you in the next file.